Motion Analysis Project, we chose to do the motion of jumping rope. The motion of jumping rope includes the three joints of the ankle, the knee, and the wrist joints, also known as the talocrural joint, the tibiofemoral joint, and the radiocarpal joint. The action of jump roping as a whole is composed of plantar flexion and dorsiflexion of the ankle joint, or the talocrural joint, flexion and extension of the knee joint, or the tibiofemoral joint, and wrist circumduction of the radiocarpal joint, or the wrist joint. The first joint we will discuss is the ankle joint. This joint performs repetitive dorsiflexion and plantar flexion throughout the three phases: the loading phase, flight phase, and landing phase. The muscles involved in dorsiflexion are the anterior tibialis, flexor hallucis longus, flexor digitorum longus, and fibularis longus and brevis. The muscles involved in plantar flexion are the gastrocnemius, the soleus, and the posterior tibialis. During the first phase, the loading phase, the posterior muscles are relaxed and the anterior muscles are contracted while in dorsiflexion. Next, the body springs into the flight phase, which the posterior muscles would be concentrically contracted to position the foot into plantar flexion. Next is the landing phase, when the anterior muscles would eccentrically contract to act as shock absorption, which allows for a soft landing. The second joint we'll discuss is the knee joint. This joint will perform flexion and extension throughout all three phases. The knee flexor muscles include the hamstrings, which are made up of the biceps femoris, semimembranosus, semitendinosus. And another knee flexor muscle is the popliteus, which initiates knee flexion. The knee extensor muscles are the quads, which are made up of the vastus lateralis, vastus medialis, and vastus intermedius and rectus femoris. Beginning in loading phase, the knee will be isometrically contracted in a slight flexion. To spring the body upward into flight phase, the quads would be concentrically contracted, pushing the knee into extension and moving the body upward, while the hamstrings are eccentrically contracted. During the landing phase, the quads eccentrically contract to push the knees back into slight flexion, while the hamstrings are concentrically contracted. The third and last joint we will discuss is the wrist joint. This joint is responsible for wrist circumduction, which is a transition from flexion to ulnar deviation to extension to radial deviation through all three phases. The muscles for flexion include flexor carpi radialis and flexor carpi ulnaris, and these are concentrically contracted during flexion. For ulnar deviation, the muscles involved are flexor carpi ulnaris and extensor carpi ulnaris, and they're concentrically contracted during ulnar deviation. For extension, extensor carpi ulnaris and extensor carpi radialis longus and brevis are concentrically contracted. Then, in radial deviation, flexor carpi radialis and extensor carpi radialis longus are concentrically contracted. Wrist circumduction allows control of the jump rope to allow it to pass under the jumper's feet during the flight phase of the motion. In conclusion, the motion of jumping rope is composed of three important joints: the knee joint, the ankle joint, and the wrist joint, but all these joints work together to produce plantar flexion, dorsiflexion, flexion extension, and wrist circumduction, but all produce one motion.